All right, guys, welcome back. This is 3.3. We're going to be talking about properties of logs and change of base. There are two review questions that deal with the work you've been doing to this point. Please pause the video and do those problems, and then I'll come back and we'll explain it. All right, so hopefully you did these. One way to do these is to plug this into a calculator. So if we just look at the first one's showing you this picture. It's log of x squared minus 25. If you notice, it's going through 5 on both of the axes here, 5 and negative 5. So it's basically telling you that it's everything from negative infinity to negative 5, and then in union with everything that's 5 or greater. So in this particular one, it's going to be everything from negative infinity to negative 5. We're not including negative 5 in union with everything from 5 to infinity. And then for the second one, if we're looking at the second picture, what we're going to see in the second picture is that it's just a normal looking log function. It's cubed, but we have an asymptote at 0. So this is going to be everything from 0, not including 0, to infinity. Those would be our first two. Today, the first part of this we're going to be talking about is when we deal with this idea of properties of logs. So the first property is saying log AB, log of A times B, and remember log being base 10 here. The rule says this, that the log of A times B is really the log of A plus the log of B. Now, where does this come from? Well, if we think about it, logs, the answer to any log, if I say log base 2 of 8, the answer would be 3. And 3 is really the exponent. It is the exponent. So any log function, the answer is going to be an exponent. And if we think about the rules for our exponents, if I have something that says x squared times x cubed, well, the rule says that we are going to add those together. And basically that's what we're saying here. We're taking an exponent and we're adding an exponent. Remember, log of A, if I know what A is, the answer is an exponent, and we would be adding exponents. That's really where this rule is coming from. For the next one, log of A divided by B. Well, just like our rule for that said this, what is our rule when we are saying x squared and we are dividing by x cubed? Well, the rule says to subtract. So here, same idea. Log. Okay, back to it. Sorry, I had to take a little break here. So this one would be log A minus log B, which is the same as the exponent rule. The last rule that we have is one that deals with exponents themselves when you're talking about a log function. This one's pretty straightforward. If you have an exponent like this, then you're going to take the exponent, you move it to the front, and turn it into a multiplication. So this one's going to say b times log of a. That would be the rule for this one. So we're going to be expanding, and we're also going to be condensing them. And when we look at these, keep in mind, these rules can go both ways. So if you start with the log A plus log B, you can always go back to log A times B. Notice as well, when you expand them, you start with one instance of the word log, and then you end up with 2 or more, depending on the problem. When you are condensing, you'll start out with many logs, the word log, and you'll end up with only 1. And we'll see that as we go further. Also, A and B have to be positive values here, and that makes sense, because if I have something that says log of negative 10 is equal to, well, that means 10, and I write x, 10 to some power has to equal negative 10. Well, there is no power. This would be something that doesn't work as well. So That's why they have to both be positive values. So let's look at this first one. Use properties of logs to expand each log and simplify as much as possible. So the first one is saying log base 5 of 3 times 17. Multiplication here means addition. So log base 5 of 3 plus log base 5 of 17. Now, each one of these only has numbers. There are no variables here. So you got to check each one when you are simplifying like this. So the first one says log base 5 of 3. Well, 5 to what power would give me 3? Well, that would be something less than 1. We don't know the exact answer to that, so we don't have to mess with this one. Log base 5 of 17, 5 to what power gives us 17? Well, the same problem occurs. I know it's between 1 and 2, but I don't have an exact answer, so you leave it like this. You are done with that particular problem. The next one says log of x divided by 100. Division means subtraction. So log of x minus the log of 100. Looking at log of x, there's nothing else to do. That one is simplified. Looking at log of 100, well, this is saying 10 as a base. So 10 to what power would give you 100? That would be 2. So this one you would have to write as log of x minus 2. That would be our answer. Looking at the next one, natural log of w divided by y squared. Division means we have a subtraction. So natural log of w minus the natural log of y squared. Looking at the natural log of w, nothing else to do. I can't expand it anymore or simplify it. Natural log of y squared, well, there's an exponent here, and I can move the exponent to the front. So this one's going to say natural log of w minus 2 times the natural log of y. That would be the answer to that one. No more expanding is necessary. The next one, the natural log of x squared divided by the natural log of e to the 17th. So, natural log of x squared minus the natural log of e to the 17th. Simplify. Natural log of x squared. Well, I have an exponent. I can move that to the front. So 2 ln of x minus. The next one has a natural log of e to the 17th. Now, keeping in mind, I'm going to do this over to the side here. The natural log of e to the 17th means I can move the 17 to the front. And when we say natural log, we are really saying log base e of e. So if I'm just looking at log base e of e, it's going to tell me the following. E to what power gives me e? Well, that answer would have to be 1, which means 17 times 1, which means 17. So this would be the simplified answer to that particular problem. As we go further, what you're going to see is natural log and e's are opposites of each other. They cancel out. So if I just drew a line through that, our answer would be 17. But this is really why it's 17. Looking at the next one, log of h to the negative 7. Well, this one has an exponent. I need to move the exponent to the front. So negative 7 log of h. There's really nothing else to do. This is the answer to this one. Some are very simple. Some take a little more work. Looking at the next one. Now, one of the things I'm going to point out to you guys, when you are doing these, it's really important that you think about what's going to happen before you actually start working on this. I'm looking at this one. This one says x cubed times y. So I know there's going to be a plus here. X cubed is telling me there's going to be an exponent out front of the log x. And then the division sign tells me there's going to be a minus. And then z squared tells me I'm going to have to move the 2 to the front. So as you do these more and more, you should be able to kind of just see what's going to happen and write them without doing a whole lot of work here. I will do this one, but that is something that you want to pay attention to. That's really going to be the case. So here we go. This one is log of x cubed plus the log of y minus the log of z squared. Now, I have an exponent in the first term that I need to deal with. I have an exponent in the last term I need to deal with. So this is going to say 3 log x plus, I don't have to do anything to the log y, minus 2 log of z. And that would be the simplified version of this. Now, one of the things to kind of point out to you as well, why are we doing all this? Why are we expanding things and making this a lot bigger? Well, you have to think about it in terms of this. Logarithms. There are infinitely many logarithms that we could create. And because of the infinitely many logarithms we could create, back in the day, we didn't have necessarily a calculator that would tell us the answer to these. What we had to do was go to a table in a book and find a value to however many decimal places that I wanted it to go to, and then I could apply that number and change all of these to pluses and minuses. And that's kind of the point to this. Changing things to pluses and minuses, adding and subtracting is a lot easier to do than multiplying and dividing. So this was a way for people to do this. Your calculators now can do all of this stuff in terms of numbers. The rules still apply, and that's why we have these variables in here so that we can actually show you the expansions. But it was an important thing that you used to have to do. For number 7, this one is saying 64 divided by y squared, so it's a subtraction. Log base 4 of 64 minus log base 4 of y squared. Looking at the first one, it's all numbers, so we have to check. 4 to what power could give us 64? Well, that one is 3. Minus. This one, I need to move the 2 to the front. So this is 2 log base 4 of y. And that would be as simple as we can get this. Sorry about that. We could end up doing a little bit more to it, but overall, that is really going to be the end result that we have. For the next one, this one's a little bit different. It says log base 3 of the square root of x divided by y. Well, x divided by y tells me I'm going to have a subtraction. The thing I have to deal with is this square root. And one way we deal with the square root is to simply look at it as this. This is log base 3 of x divided by y raised to the 1/2 power. Now I have an exponent, so I have to move the exponent to the front. This is going to say 1/2. And then inside here, I'm going to have log base 3 of x minus log base 3 of y. Now, sometimes they say you can leave them like this. Other times, because it says simplify as much as possible. Well, simplifying as much as possible really means you have to say 1/2 log 3 of x minus 1/2 log 3 of y. That would really be simplifying it to its end. Sometimes they just ask for this first one. But in this case, it says simplify as much as possible, so we are going to be doing that. This next one, basically the same idea here. Natural log of the cubed root of x times y. So x times y tells me there's going to be a plus. And then I need to rewrite the cubed root to say to an exponent of 1/3. So this one is going to say the natural log of x times y to the 1/3. Bring the 1/3 out to the front. And then this is going to say the natural log of x times the natural log of y. And then distribute. We're going to get 1/3 natural log x. Sorry, back here. See, I'm saying times when this is actually a plus. Hopefully you caught that right away. And then plus 1/3 ln of y. This would be our answer simplified. As I said, as we go through more of these, you really want to start paying attention to what's happening first so that you don't have to do more than you need to. This next one, looking at this one, log base 8 of, we have 64 divided by the square root of x plus 1. So I know I'm going to have a subtraction. And I also know I'm going to have to raise x plus 1 to the 1/2 power so I can move it to the front. When I write this out, it's going to say log base 8 of 64 minus, now keep in mind the half is only applying to the denominator part, not to the numerator part. This is log base 8 of x plus 1 to the 1/2 power. Simplifying, log base 8 of 64. Well, those are all numbers. 8 to what power gives me 64? That's 2. You should be getting used to that by now. And then for the second one, I got to bring the 1/2 to the front. And it's going to say log base 8 of x plus 1. I can't really do anything else with this. This is expanded and simplified as much as it needs to be. Looking at the next one, we have a log of the 4th root of 1000x. So I know I'm going to have a couple things. I'm going to raise 1000x to the 1/4 power. And there's a multiplication between the 1000 and the x, which means there's going to be a plus. So we're going to have the following, log of, and then this is going to say all of this is 1000. I'll just even put the times in here so we see it, raised to the 1/4 power. That means 1/4. Then we got to multiply through. This is going to be the log of 1000 plus parenthesis, because we haven't finished that part off yet, the log of x. And then once I have that answer, I'm going to distribute through. I got to simplify where I can. So would you agree that this is going to say 1/4 log of 1000? 10 to what power gives you 1000? Well, that's 3. Plus, this one is just log of x. Multiply through. 1/4 of this is 3/4 plus 1/4 log x. Hopefully you guys are kind of seeing how this is working, what it is you're working toward. So this next one, I'm just going to do it. I'm going to write the answer. I'll write it down at the bottom. You can go through the steps if you need to. This is a multiplication. I know this right here is going to be raised to the 1/2 power. And I know I'm going to be dividing, so a subtraction, and I'm going to have to move this to the front, just like I'm going to have to move this one to the front. So here we go. Every piece has to have that. So we got a multiplication here. First one's going to say 4 ln of x multiplication plus, I got to bring the half to the front, 1/2 ln of x squared plus 4. You don't have to do anything else to that particular piece because x squared plus 4 does not simplify in any way. And then the second part of this, minus, we have a 7 here. So minus 7, then it's going to be ln of x plus 4. There's nothing else I need to do. This 2 right here, the squared term, isn't not part of the whole overall term, so I don't have to move it. This is the answer. If you have your note packet, leave space, do the work. That's what I would tell you to do. Go ahead and take a pause here and then do this next one and then come back and the answer should be there. So this one I broke all the way down, the first step, and then I moved everything. This is what it should look like when you're done, but if you did it all in one step, more power to you. Like I said, these should be something you start seeing and then getting a good picture of what's happening, and that should be your answer. Moving on to this next page. Now we took them apart, so the next logical conclusion is to put them back together again. It says write as a single log with a coefficient of 1, simplify logs when possible. So here we go, starting with the first one, log of 11 plus log of 17. Well, the plus tells me that we're going to multiply, and we're just going backwards of what we just did. This is going to say log of 11 times 17. Looking at that, we can condense that a little bit further. This is going to be log of 187. And this would be our answer. Now notice, I started out with the logs, 2 of them, and I ended up having just 1 instance of the word log. And that's really what you want to look at here. When you're putting things back together, you are going to actually put them together in such a way that you only have 1 log and then doing everything else. What is the negative here telling you? Well, the negative tells you that you should have a division. This should say log of 17 divided by 3. I can't simplify that anymore. 10 to the some power gives me 17 over 3. That's not really going to give me an answer I'm really excited about. So this would be our answer, putting them back together. How about the next one? It says the log of 3x plus 7 and then minus the log of x. Now, I know there's more going on right here, but it really doesn't matter what's going on right there. The minus is the important part. It's saying we are going to divide. This is going to be the log of 3x plus 7 over x. And you should be putting things in parentheses so that you make sure whoever's looking at it understands all of that is being affected by the log. Next one, there's nothing to reduce here. Don't get too carried away with that one, because when you do something like that, x can't divide into just the 3x up top. It has to divide into everything. So can't reduce that fraction, but you do have to check when you do have fractions. This next one is saying 1/2 ln of x. Well, what is that telling you? It should be telling you that you would move the 1/2 back to the exponent of the x, and x to the 1/2 power is really the square root of x. The plus is telling me I'm going to be multiplying, and I'm going to be multiplying by y. So when I look at this one, first thing I would do here, and I'll do it by steps, but you should be able to just do this one. This one's going to say natural log of x raised to the 1/2 power plus the natural log of y. And then I'm going to just rewrite it. It's the natural log of. Now, this is going to say the square root of x times y, which really means the natural log of y root x. That's really what this one's saying. You could write the y at the end, but then sometimes it's confusing. Is it the y supposed to be in the radical, or is it not supposed to be? Better to just be safe, write it out front. How about the next one? Well, they're all pluses. That means we're going to multiply all of the variables together. So this is going to say log, and then this is going to say R-I-D-E. I know it's lame. Log ride. Woohoo! All right. A little bit of math humor for you. This next one, looking at it, what's going to happen? Well, we're going to move the 4 up to the exponent. We're going to move the 9 up to the exponent. We're going to move the 7 up to the exponent. Here's where it gets a little more interesting, though. Notice this one says minus, which means there's a division, and then this one says plus, which means there's a multiplication. It might be worth your time to understand the following. You could rewrite this. You could just say this is 4 ln, actually, and I would even maybe say it, do it this way. Here's ln of x plus 7 raised to the 4th, and then move this one over, plus, this is ln of z to the 7th, and then minus ln of x. Sorry, and I did 9. ln of x to the 9th. I'm moving all my exponents and I'm just rearranging it. And the reason I'm rearranging it is pretty straightforward. Any negatives, any minuses should be division problems. That means they should end up at the bottom of your fraction. And it doesn't matter how many negatives. What I'll show you in one of these problems, I think it's coming up here, that when you do this, you have all these negatives, but it's kind of a distribution situation, and we'll talk about that. First of all, What's going to happen with these? Well, you're going to have ln. You're going to have x plus 7 to the 4th times z to the 7th, and all of that is over x to the 9th. That is what this one's going to say. So anything negative goes to the bottom. Anything positive stays at the top. Let's try this next one. We're going to move the 1/3, right? We're going to move that up. Actually, we're not going to move that. We have to distribute the 1/3. Actually, we don't. We could just do it the way they did it earlier. This plus tells me there's a multiplication. Always deal with what's inside the parentheses first. Deal with what's outside later. This is going to go as an exponent right there. This will end up moving to the exponent right here. The minus tells me this is going to be a division problem. So here we go. I'll do the first part just so we see it. This is going to say log base 5 of, this is going to be xw raised to the 1/3, and we'll rewrite it in just a minute, minus, this is going to be log base 5 of x plus 2 squared. And then to finish this problem, we would then make this a division and write it as 1 log. So log base 5 of, this is going to be the cubed root of xw over x plus 2 squared. That would be our answer to this one. Lots going on in that one. Just take them step by step. If you see parentheses, always go from the inside out. So I'm looking at this one. I see a set of parentheses. Nothing really has to happen here. This says x, and this plus is telling me these two are going to get multiplied. And then it's saying there's a minus log 17 and there's a minus log x plus 5. Here's what you want to think about. These are both minuses. So if I rewrite this, it's going to say the following. Log of, I'm going to rewrite the whole thing here just so we see it. Log of x plus the log of x squared minus 25 minus, I'm factoring out the negative, log 17 plus log of x plus 5. Now, here's where it's going to get interesting. Keep in mind, multiply here on the first part, the first two, and then it says minus. That's where your fraction is going to be. And then these two need to get multiplied together, the 17 and the x plus 5. That is something you got to think about. If you have two negatives, they're going to get multiplied together, but they'll be at the bottom of the fraction. So in this one, it's going to say the following. Log of, this is going to be x times x squared minus 25 over 17 x plus 5. And we'd be tempted to leave it right there, but we can't leave it right there. The reason we can't, because I can factor x squared plus 25. So log, this is going to say x. This is x minus 5, x plus 5 over 17 times x plus 5. Well, these two can cancel out, and that's going to leave me with an answer that says log of, at the top I'm going to have, and you can multiply this through or leave them out, it doesn't matter. This will be x minus 5. So x times x minus 5, and the bottom says 17. When you have fractions, you always have to check to make sure. The other thing to point out to you guys, just so that we're clear, in this particular problem, but not so much, you've got to check all the pieces before you start putting things together. Because if you have something that can be simplified, let's say it said log base 5 of 25. Well, that's 2. And so we don't need to put that together. We can just say plus 2 at the end. We'll see some problems like that, so just keep that in mind. This next part, change of base. Change of base, this was used when calculators could only do log and natural log. You will need to know how to do change of base. Just because your calculators say that it can give you the answer using the calculator itself. You still have to manipulate these things. It will still be important. So do not skimp out on this. I think on the test, we ask you to do a problem where you have to use change of base. So just get used to it. In this case, every log expression can be converted into common logs or natural logs. So log base b of x, we could write this two ways. Log of x over the log of b. What has that done for us? It's changed both logs to base 10, so I can use my calculator to solve that. Or it can say the following: natural log of x over the natural log of b. It will give you the same exact answer, but these are two buttons on your calculator that you can use, and this is why we teach it to you. Use common logs or natural logs to evaluate to 3 decimal places. So for this first one, it's going to be, I'll use log for the first one, log 17 over log of 4. So I'm going to need my calculator for this. I'm going to say log of 17 divided by the log of 4. I get an answer of 2.044. So 2.044. And if we watch this, if I did the natural log of 17 and then divided that, make sure you close your parentheses, divided that by the natural log of 4, I will get the same answer. So it doesn't matter which way you do this. For the next one, it's saying the log of 3 of 0.456. So natural log of 0.456 divided by the natural log of 3. A lot of people like to use the natural log better. Really doesn't matter though which one you use. So natural log of 0.456, close my parentheses, divided by the natural log of 3. We end up with an answer that says negative 0.718. So either way you do it, should give you the same answer. Now this one, it's saying relate this to solving basic exponential equations. Well, 12 to the x power is equal to 6. We're going to solve this using a log, because in order to solve exponentials, you got to use logs, and if you want to solve a log, you got to use an exponential. So this is going to say log base 12 of 6 is equal to x. Now, this is just like above here. We're just going to rewrite it. X is going to equal, I'll use natural log here since it already has logs. Natural log of 6 over the natural log of 12. Remember, the base number, the base whatever it is, has to be in the basement, has to be at the bottom. When we do this one, it's the natural log of 6 divided by the natural log of 12. Remember, you can't just divide 6 into 12 and get 2 at the bottom. It doesn't work like that. 0.71 or 721. 0.721. Going to do the same thing with this one. Looks like there's just one extra step we have to do. So this is going to say log base 7 of 18 is equal to 2x. So x is going to equal 1/2 of log base 7 of 18. So when you rewrite this, and keep in mind, I didn't say this, equivalents. These are equivalents here because we had to round. So equivalent measures. 1/2 log, let's do it this way, 1/2 log of 18 divided by the log of 7. The equivalent answer to this is going to be the following. It's 0.5 times the log of 18 divided by the log of 7. We're going to get an answer of 0.743, approximately. Hopefully we all understand that. So it says if b to the x is equal to a, then x is going to equal log base b of a in this case. And then the last part of this, it says graph using change of base and a graphing calculator. Label the domain, write the equation of the inverse function. So here we go. You're writing things as an inverse here. In terms of that, how is this going to look? So using change of base and using a calculator. Change of base means simply this. We are going to, hold on one second, this thing's freaking out on me. We're going to do the following. We're going to say y is equal to, this is going to be the natural log or log, you can use either one, x minus 1 over the natural log of 4. And then we're going to plug that into our calculator and see what we end up with. So y is equal to, we're going to say the natural log of x minus 1. And we're going to divide that by the natural log of 4. And when we graph it, we're going to see a graph that looks something like this. And we've seen these graphs before. Before I actually graph it, it's saying to do a couple of things. Number one, they want us to explain, first of all, the domain. Well, the domain is going to be everything from 1 to infinity. We shouldn't really even need to do anything there. The inverse function, so to find the inverse function, I'm going to be doing the following. I'm going to switch my x and y. Or you can just understand if h is 1, then k is 1. And then it should be 4 to some power plus 1 in this case. But we'll do it the long way. So this is going to be switching your x and y. To get rid of the thing here, the 4, remember it's going to be left to right is equal to the middle. If I wanted to switch it around, it's going to be 4 to the x power is equal to y minus 1. So then it's going to say y prime, or the inverse of y, is equal to 4 to the x power plus 1. That is the inverse. They wanted us to just graph the regular one here. I know there's an asymptote line running straight down here at 1. And then I just need a couple of points. Well, this will tell me a couple of points. 0 is an error, 1's an error. 2, 0 looks like one of the places I can cross. And 5, 1 actually looks like a solid point there. So this is running up along here, coming across and going this direction. And that is the end of this particular one. I'm sorry it ran so long. There's just a lot of information in this one. Hopefully you guys understand it. We get on with this and keep working toward this test before we go on break. Have a good rest of your day, guys. Bye.